Welcome to my talk about TypeScript patterns and better React components. First of all, welcome to Porto. So it's my first time in Porto, so therefore first time for me also at Porto Tech Hub. So apparently, I think it was last year was Porto Tech Hub, so it seems like a nice conference, a lot of nice people here. And it's also my first time in Portugal here, actually. So if there's anything you want to show me interesting, I think most of you are from here. And if there's anything interesting you can show me, please reach out to me after. I think I'd be super interested. And also, I don't know if they still understand that, but I want to do a huge round of applause for the organizers for really awesome. First, I want to introduce myself. I'm Reyes. I'm also Reyes on most of the social medias, but without the E's, so just skip the E's, then we get the Bloomers. You can find me on the internet, also on my website. Through my website, on Reyes.com, you will find most of the important stuff that I do and more ads and things like that. So I am a software engineer and also a workshop instructor and tech speaker. And currently I work for a company called Cadena. I'm doing developer relations there. And what is Cadena? So Cadena is a blockchain company and a platform actually designed for scalability and security. We do things like Cadena.js there, which is a collection of JavaScript, TypeScript tooling for interacting with the blockchain. And it includes things like React components, like Reyes, apps like docs, sites, I think many things around TypeScript. So yeah, with Cadena being a blockchain, of course, we also have our own smart contract language, which is called Act. And this is basically similar to Solidity, designed from the ground up to support unique challenges of developing solutions to run on blockchain. And also we have Marmalade, which is our NFT standard smart contract system on the Cadena. But we are here to talk about React, right? So, and specifically this talk, we'll talk about typing in React. But before that, I want to reflect on quickly the history of typing in React. So, for me, when I started learning about React, I think it was around 2014, where I first heard what it is, what it's like. What's the stupid HTML again? With, it's JSX kind of syntax. I was thinking back in the days. I think back in the time I was using jQuery, and I thought there's nothing better than that currently, And we even built a lot of websites with vanilla JavaScript and things like that. And I thought, yeah, I'm Jane, And by the time React actually was first introduced to the open at around 2013. And I think even before that, the React team had it used internally around 2011, 2012. And the interesting thing is, when it was introduced, it came already out with some sort of typing. So you had runtime typing on your props, which was called prop types. So that was basically built into the React package back in the days. And yeah, worth to note, yeah, as I mentioned, React was already used 2 years before production with Facebook. And also, around 2014, they open sourced actually a static type checker solution with ASM, Facebook, which was called Flow. And that was also around this time where I got type checking around. I think it was 2 years after, so 2016. And later, about 1 or 2 years later, I found out about TypeScript, and I was like around 2016. It was super into Flow. And when TypeScript used, I thought like, no, I'm gonna use Flow. That's gonna be the thing. And then you learn other ways on building apps that are safe to type with, especially like different languages, like Elm or Reason. And I don't know, anybody here have heard about or used Elm or Reason? No one, crazy. It's basically something that is that has focus on expressiveness and safety, and they were meant to be like super fast, super expressive, and they basically code leverages or compiled then after into JavaScript. Now I think Reason is even rebranded to Restrict. That makes the compilation to JavaScript even more understandable. Then, when I started adapting actually TypeScript, I think that was around 2018, so I said, okay, the community seems to be going into TypeScript. That's the time where people kept moving everything into TypeScript, so libraries, frameworks. I think I think the support was basically skyrocketed by the day, from that day. But what about today, and even beyond today? Maybe TypeScript takes over, and then JavaScript will be just like what we think about machine code right now, that doesn't make sense anymore, or something like that. Or maybe AI takes over, and we don't care as much as in, So let's talk about TypeScript today. So from the beginning, Angular and early on and until today has a strong and early association with TypeScript. And so has Vue 3, which was, I think, released around 2020 in September, which was from the ground up written in TypeScript. So TypeScript has been tightly integrated with this nice frameworks, but not React. Today, TypeScript is not tightly integrated with React. The way you type TypeScript is actually very, very unopinionated. And you can actually use TypeScript and also use prop types, and you also can use even Flow on top of that, or you can type it with whatever you want to do. And we've seen starters, boilerplates, libraries like Create React, for example, which was one of the first very popular boilerplates back in the days, created in JavaScript, then after adapted basically TypeScript. Next.js, for example, initially it was written in JavaScript, and then by the day where TypeScript was more has been more common way of typing apps, they adopted TypeScript and started rewriting stuff into TypeScript, and Remix also. And in fact, if you look into the React source, you don't have to read it now, but you see most files annotated with Flow at the top, and sometimes they are typed with Flow. So I think most of the code is being used basically internally, and they use Flow. And the rest is basically all in JavaScript. So TypeScript types for React actually are purely driven by the community, and which you can find mostly in this definitely type cluster in GitHub. I think that most of us really know or familiar with. So when React is publicly open, it didn't actually take long until the TypeScript community added community types into React, which in general, I think it's a great thing that there is something that is not driven by a single company or by a single entity, but by the people that are actually consuming this. And I personally like that it's not too tied into TypeScript as well, even. So it's universal to any solution, and maybe in the future, I don't know, maybe something else picks up, and then maybe we want to use something else in TypeScript that is more superior that might appear. Now, let's talk about TypeScript patterns. And let's begin this next couple of slides with some simple patterns. So unit props, for example. So we all know they're supposed to be used for states, but not like any states, but more when you have exactly two different states, like disabled, empty, or checked, or not checked, right? Whereas if you have, whereas if you use states that could have like multiple or more than two states, like a variant where you have primary, maybe secondary, and then maybe tertiary, and then maybe something outline or something like that, you'll quickly notice it will be odd that you use them simultaneously like that. But with TypeScript, it's actually possible to use that in a way by writing discriminated union types. And basically, when you then try to use them simultaneously, you will get the TypeScript error after that. And yeah, the point with that previous slide is actually that you write more code afterward. So why not just using like that with a selection of union types, which is less code and compared to the discriminated unions. And what I personally found out also is if you use just similar union types, it doesn't cover also your IntelliSense auto suggestions compared to the other one, because it kind of like adds a lot of things as well. If you just try to get auto suggestions out of the props instead of the string level unions from the prop. But what about enums now compared to string level unions? I think there is often like also debate of whether you should have this multi-state thing with string literals or maybe enums. So what to use, And there are some couple of notable differences that comes with enums. So I think one of the major ones is that the type or the value that you define in your enum is distinct. So this means if you have two different enums, but both contain the same value. So for example, you compare fruit, the red value from fruit and color, it's not going to be the same, even the value is the same. But on top of that, enum is a little bit more concise with how you type string literals. But the problem is if you enumerize everything, you probably on a real code base, you get to a point where you have like a huge amount of import types that just includes probably enums or maybe some other types as well. So it clutters your import statements. And also, probably you don't notice it that much, but if you compile an enum into just raw JavaScript code, it actually adds a lot of boilerplate into your compiled code. Whereas compared to just string literals, you have just this for one string literal, like a single line. Now, Boolean unions, enums are great for passing component states. But sometimes you may have seen them written as, like a super custom component. And I think what I want to touch base here quickly is when you use them now, custom components in React. Should I use primary button making component, or should I just use button variant primary? So when do you decide? So I have here a strategy that worked really well for me. So as for the custom component, I think it should be more for actionable components that are implemented, that are that has like predefined logic built in to the component. So for example, like a button that's like tightly integrated into your form, like a submit button, that automatically handles like loading states or disable states that is coming from the form library. So and this component is more like tightly coupled with the form. So it's kind of like if you compose the button with some form element on top, they are more interconnected kind of. So but I think what's worth to note here is that the appearance, it doesn't change anything of how it's styled or something, but it's more like it adds like a little more of logic, or it adds more action. It's more actionable. Now I want to talk about enhancing components with HTML element attribute types. It's a long word. There is a variety of ways on what type to use in React for enhancing something with HTML attribute types. And this is like not even an exhaustive list, but it is like a thing that most people have encountered while trying to figure out what types to use. And in the beginning, it may not be super clear what does what, and it can be daunting to find out. So I'll explain you each of them, everything in detail what they use. Components with HTML attributes do not include enough types, or they provide you more global types. So instead of, for example, in this case, when you have HTML button element, you try to find out what type the type prop is. It's gonna be, in this case, just the string. Or actually, it doesn't even. Oh, sorry. In this case, it doesn't even exist because I think so. So this type basically just includes that most of the other elements also include. This one actually was the one I was talking about. So React HTML props, basically that uses all HTML attributes, is the one that actually includes inaccurate types. So for example, if you have the type prop that is in this case just typed as a string, whereas it could be for an HTML button element, a submit or a set or button or undefined, right? So it's not precise enough to provide you with types, but it's correct, right? And then if that's not good enough for you, there is going to be something called JSX intrinsic elements, and then you put the element as a string, and which is not bad, and it actually is very accurate, but it errors when you try to inline it. So for example, if you try to extend it in an interface. But what actually works is you can still use it and then wrap it with this TypeScript closed-in utility type called non-nullable, and then you're good to go. And then this works. This is like super precise. And the thing is, there is other types that does the same thing without wrapping anything with with utility types. For example, React population attributes, which is now much better than what we've seen before. Now, if you compare this actually with something called component props, it's one-to-one same thing, except button HTML attributes is just written for a couple of characters longer than the other ones. So why not just use component props, right? Now, the true ones to use are really React component props. And specifically, if you're not if you don't prefer to be like very specific whether your component will be wrapped or will not be wrapped with a forwardRef function, then consider component props. But I think best is that you know beforehand whether something is wrapped or not, because then you have like a little bit more conciseness in your typing. Use component props with ref and then as your element. And at the opposite, if you don't expect, or if you're sure you're not gonna wrap it ever with forwardRef, just use the other one. Now let's talk about React.function components. What it basically does is it attaches a couple of properties to our component that is great and that it's useful for tooling and providing more contextual details to components. For example, it adds like this prop types prop that you can then utilize with the prop types package. It adds context types, default props, display names. So it's really nice, it's really handy. And it's actually been different in the past before, I think until React 17, it used to be typed, it used to add implicitly a children prop to your type, which is not the case anymore right now with React 18. So here's an example how you can, for example, like attach display name with a just regular function component, which is really, really handy. So it's useful for things like if you work with dev tools, debugging, or if you write like third-party libraries. So yeah, definitely make use of display name, especially if you have anonymous functions where this tool can't figure out a name for a function. Nowadays, we may be building a lot things with React Server components. Anyone here uses React Server components or have heard about React components? Or React Server components, sorry. Not many. Wow, crazy. So that's a new way of how you basically write components. Basically, the components that you write here are not ever going to be on your client. So they just so the server is basically just putting on your HTML, and the entire code that you write here is not ever going to be in the document and the client. So these components are actually super special because, as mentioned, they run on the server and never gets to the client, and they can be written asynchronously, which can include like promises. So you can fetch anything like data, especially, or even you see a lot of examples where you fetch directly from databases and then just render it in your return function statement in the render function. And this used to be incompatible. This just used to be incompatible with TypeScript. But since some TypeScript version like 5.1, it's possible to have it in our return as a promise directly. So if you consider using React Server components, make sure that you're at least at after 5.1 to have React Server components fully compatible with your TypeScript compiler. Now, reusing types and interfaces. I think it's a great way of avoiding duplications, and it's less maintenance overhead. And I personally like also to export only my consume elsewhere. So using utility type or write out simple types. I think it's a challenging question, but I think it boils down mostly whether it should be more readable or whether it should be more accurate, right? So for me personally, I think it depends, but I like also the accuracy. So for example, for a simple z-state function, I think I like the React dispatch utility type. But I think it just depends also with who you work with. So when your coworkers start complaining how unreadable code gets, probably it's a good idea then to reconsider very simple typings just as like in simple ways also. So prefer usability and keep simplicity on a case-by-case basis. There is like no one fits all solution, but I generally think that just talk to your teammates. What works best for that. Now I want to talk about compound versus polymorphic components, and to describe this a little bit more in detail. So compound components is here meant to be more for where you have the customizations managed by the task component itself. Whereas polymorphic components, the customization is managed by the primitives or direct parent primitives component. I think one great example of a compound component merging crops together is the one using from Reyes, which is called, that's basically a prop where you just say as child, and then this tooltip trigger component basically applies the elements that you have in your child. I think it's Reyes slot, UI slot, it has like this as child compound. So I put up a simple marking condition of this where you can see your slot. So how you built this is basically a function of slot. And what's happening here is that you check basically if the children is a component, and then when it is, you return or you call React.clone component, pass it with job, and then merge the props together with your parent prop. So you spread props, and you spread lots of children props. And otherwise, just return your reaction component name. And on the example with the button, you will have your button, and you check whether it has as child props used or not, and render the slot for the button, and then spread the props also on the component. So it's a very simple explanation of how this pattern works. So, and also, Polymorphic, on the other hand, I think it's a great way to generalize customizations of elements and components. So implementation is, I have to say, is not very trivial to create a component with super strict typings. But here is an example of strictly typed Polymorphic components. And I have to warn you, this is like one possibility in how we do that. But it is not compatible with everything you may want to use this example. If you want to wrap this with forwardRef and then put a subcomponent on top of that or attach it, it may be incompatible. But it's one way. I think it's one of the cleanest way I've ever seen to type it that way. And I think in its core, it's essentially just calling React.create element. You don't see it here because I'm just using component capitalized and then returning this as an poly, and then pass the props like this. You can also write components that have or that passes generics. And I think it basically allows you to pass generic types directly to your JSX component like this. So, for example, form provider want to provide it with some form data or something, and in this way you can have access to some form information, format information within your form and whatever you want to do inside of that. And I think it's great if you have like hooks or something that needs and more details from the values you're dealing with. Next is rec.forwardRef. So I think typing components rep and forwardRef should be like pretty straightforward. So if you first time use it, you see that you pass at least two generics. So one for the element and then second one for the props. And then you should be good to go. Until you want to type the component, or until you want to use a component that has generics itself. So that was one of the challenges that I had in the past, and it was quite tricky to get this done right. And there's, of course, multiple ways to get around that, like with type search or any, and then voice always, so any sort, voice always thing. But I think the cleanest way to do that is with augmenting total graphs. And what you do basically here is you have this in the top section where you have declare and object React, and then you add basically some generics to your render function that basically applies to this generic types. So I think this feature is called higher order function type inference that allows basically propagating the free type parameters of the old function that's basically happening. And then once you have that in place, you don't have to pass generics to your forwardRef function anymore, but instead just use your component as is with generics and you're ready to go. And I think this article is like super brilliant if you want to learn more about this, and it's explains also a little bit more in detail, so definitely check it out. I'll also post the QR code in the last slide that I have that includes all the links and all of the interesting references throughout my presentation. Now, React.context. Anyone here has been working or has built React something into React context? Awesome. Yeah, I think it's super fun. It's very important. So here's how you type context with when you have something with default values, right? So for example, theme context, you basically provide it with default value with light. You have theme context type as the type defined. And then you pass the same type listen to your use state and also provide use state default value. So these are default values of kind of duplicate the default value, and then pass it to your provider, right? And then basically, in the end, you just use the context and then it's fully typed. Whereas with without default values, it's a little bit different. So what you have to do is you have to provide a type that is a union with a null, and you just provide null as a default value. And then what you have to do in the end for your clusterbooks or for anything, you have to check. So if you given you expect some value, you have to check whether the value is there or not. So you mean on a handle in this case where there is no value, because otherwise you just add for everything the inalienable value. Now let's talk about overload function components. I'm pretty sure it's very rare to do something like that, but essentially it's similar to discriminated unions. I think it's great for using props that are created in conjunction with some other props. So, for example, we have the data display component that displays either currency or either unit or a plain text. So, for example, for currency, so if you use type currency, then it enables you the prop type the currency prop when you use that as a type currency. And same thing with if you use like unit, then it enables you the unit prop. And if you use plain text, then just have a string with value. I think it's a great way to add more conciseness to your typing to your type with your props. Now, since we are typing a lot of props, many of us type it as type or as an interface. So what are here the differences and what does it cost about that? So personally, or generally, types are more concise and easier to read, and it allows you to override the types by doing intersections. The thing is, with types, you cannot add additional members. Whereas with interfaces, you can extend it with other interfaces, for example, which is a little bit safer than intersection types, I think. And I think also it's great for enhancing third-party typings. So, for example, if you use something else, just extend it with something you only may do, which adds a bit more typesy because you don't really override something that is existing. But the thing is, you can't really override types once they're there. So it's kind of like good, but it's also bad. But in my personal experience, I had a case where we had like everything with types, but it was just shorter and it was just easier to work with. And at some point, for me, I had this situation where I saved, and then it took me like 5-7 seconds until it actually saved. But we didn't find out what it was, and we still didn't know. We still don't know what it is. But it must have been something after we had replaced some of the simple types into the interface that it introduced something internally, like a loop or something, where it just kept computing the TypeScript compilers and things like that. I don't know. It was something that helped me reducing some computational work, right? Just using interfaces were awesome. But I'm still using a type that is not possible. For example, if you pass a prop that is intersecting with the exact same type, so kind of like more dynamic types, right? That being said, I would prefer interfaces where possible for taking advantage of the TypeScript compilation in your editor. And also on that note, I also encourage actually, type indentations, especially if you have functions where you return something for fast combination. I didn't know that it actually helps a lot. And I'm not just saying that because it's something that I want to do. I actually found out about that in the official Wikipedia of TypeScript that has a performance section, and it's actually saying that if you just return your type notations, if you type your return types, that actually reduces option more for compiling. So actually, it's a good thing to put extra with hard-coding types into their return types. And yeah, it's the official TypeScript repository. Although I think so comment types. Although I think it's super straightforward and trivial, I still think it's kind of like underrated in how to help your teammates to be more productive. One specific example that I super like a lot is when I work with digits, for example. So specifically when we use the format action of that. It doesn't look trivial in the beginning, but I know that DJS in the format function has some shorthands how you can format something. So everyone probably knows dd, mm, yyi. Of course you know that, but there's a lot more shorthands that you only that I always forget about. And the cool thing is, once I use that, I just tap in the link in the bottom, and this basically gets me into the website where everything is like all shorthands are explained in detail. So definitely take advantage of like comment your types in TypeScript, because and then reference to somewhere. This word super nasty. I've seen also like a lot of examples for deprecating types, especially if you have like a lot of if you have like very frequent release cycle and then you have keyword, no props. You see this right through to some types and then explain that basically in your description what you should use instead or something like that. So this is super helpful. Now I want to talk about everyone's favorite type, right? It's basically or middle, but it's also mine. So how do you get around that, or how do you deal with something that is just basically any? So I think a very common example is results or your data response of the fetch function, for example. I think many of us have seen something typed, casted into something. But the point is, if you do that, of course, mostly probably it will be correct. But it's not correct. There could be a case where just errors and it just is not fact. You don't get the data, and then you still have the database ones fact is that. So how do you get around that? So one of my favorite way to do it is to use runtime parsers. So I think it's very useful and simple, and popular one is Sloth for doing that. And it's actually similar to in the past where we've been using prop types, and it's just not typed for this prop types. It can be you can runtime parse everything basically and just returns the correct TypeScript types out of us, and you do that and never pass that. And then it also can handle errors if it doesn't match this field cat. And of course, I need to mention that here, since we're talking about TypeScript, not only any, but also your as second best friend and the exclamation mark for basically the non-type assertion here. So yeah, avoid them all, please. And this needs to be mentioned here. So yeah, quick example how they are used. So as a number, for example, you use here is just make it a number. Same thing like here, whenever this type will be at the end, to just force it to be this type, right? So To get around this, there's multiple ways to do this, but I think the most trivial one is to something hard to use content check tab bars. So you could do check whether the data is resolved, especially for primitive types. Whether it's a number or not. So check what is the number and then return the data, or just return whatever you want to spare that. Okay, there's also solutions there, just your alpha function that does this simulation. Now, about tooling for helping you be more proactive and helping you think less about these kind of things. I think this is something that you should definitely consider because it touches everyone that works in your base, and I think it's really important to have that really perfectly in place and to try to automate wherever it's possible. So with that being said, I think rating feature code is just clean without asking afterwards. So better earlier than later. And you probably may use most of this that I have here on the screen. It's just a reminder to think that the tools are here to help you not to make things not complicated. So definitely spend maybe a little bit more time, even if it's a day or maybe it's a week. That's a lot better than your other 4 teammates spending the same time, but 10x than that for sitting with things like that. So here are some examples. I put my easily configured button, which uses most of the stuff that I like to use. So it includes like a lot of things, like all fixes and rewards and things like that. So check them out if you don't lose them. And the last thing I want to talk about here is about the configuration. And I think the most trivial one is to use something strict true. This basically adds a lot of things out of the box for you. But there's a lot of things it doesn't include actually, or it's not included in the strict. So strict true or the strict configuration, basically a set of many other configurations that use config, which is really, really cool. But there's a lot of other things that may be more precise with your typings. So definitely check these out. And I want to focus on one specific example here, and this one is in unchecked index access, like this. What this basically does is, if you have the list of something, oftentimes it just infers it into the type of this list, which is most of the time probably okay. But if you try to, for example, but the problem is the list can also be, completely nothing. It can be empty. So if you try to access, for example, the first one of the list by its index, then you get undefined, which is not correct anymore. And this one basically types it correctly if or undefined. It just can get messy if you just have big queries and try to send alphabet. So then it works correct. Now, that was what I was showing to you, and before I wrap up my talk, I just want to remember you to remember that the types aren't here to fund the arrows because it's so unreadable. So TypeScript is basically here to give you more confidence with your code. So all the patterns that I've just showed you are for helping to increase the maintenance, the components that I've struggled with personally. And yeah, I think that's it so far. I hope you have learned something out of my talk. If you have anything that is still like a question mark for you, feel free to reach out to me. With that, embrace the power of TypeScript, but don't take it far. You can find my slides and some interesting names and all the resources here in this QR code. This link on Linktree. Thank you everyone, and enjoy the rest of the conference.